Hi friends, I am Yashwardhan and welcome back to my YouTube channel. Today I am going to tell you how we can create a microstrip rectangular patch antenna using HFSS software. This is the antenna which I am going to design, and this is consisting of the following parameters. Following dimensions. Now now my rectangular patch antenna is consisting of a rectangular patch having the following dimension. It is consisting of a lambda by 4 transformer line which is having the following dimensions, and it is also consisting of a feed point where we are going to give an input or excitation, and this outer rectangle represents my substrate. Substrate is the material on which we are going to design my rectangular patch antenna, and this is a cross-sectional view this in which my height of my substrate is 1.6 millimeter, and my ground and below the substrate I am having my ground plane, and these are the dimensions that I am going to use for my design. Now before we proceed to design this antenna in HFSS, let me clarify one thing. I am going to design my antenna in XY plane. To do this, that is, I am considering this direction as my X direction, and similarly I am considering this as my Y direction. That means whatever the dimensions I am having here, these will be along Y axis and this will be along X axis. Now with this out of our way, let us proceed to designing our antenna. Okay. Now to do this, first of all, click on the HFSS software icon that is available on your desktop, or else you can type in the search bar HFSS software and open the software. Now after you open the software, first of all, right click on this project one and click save as. You can do this step after once you have created design and before running the simulation. Then go to the third option and select the place where you want to store it. I have also selected this. Let me name my project as patch antenna and click save. Now to begin our design, first of all, insert HFSS design icon and our XYZ axis is created. Now before we begin designing our antenna, first of all, go to HFSS, go to solution type and select it as driven network analysis, click OK. Then go to modular, go to units and select your units as millimeter and click OK. Now we are free to begin designing a microstrip rectangular patch antenna. To begin with, let me first design the rectangular patch. To do this, click on draw rectangle, or else you can click on draw and go to rectangle, or you can directly click the draw rectangle icon and draw one small rectangle. Now rename your rectangle as nothing but my patch. Give its color. Let me say its color is nothing but, let me say it's orange color and click OK. Give the transparency as 0 and click next. Next, let's move on to its dimensions. Now from the figure we can say that its y dimension is nothing but 17.56 millimeter and the x dimension is 12.56 millimeter. Now that's what we are going to type here. Our x dimension is nothing but 12.56 and our y dimension is nothing but 17.56 millimeter. Now what will be its position? Its position will be nothing but, its x position is nothing but negative of half of this distance, which is nothing but 6.28 millimeter. Its y position will be nothing but negative of, because it will be in the half will be in the negative y direction also, half of this distance, which is nothing but 8.78 millimeter, and our z dimension will be 0. Z position will be 0 because we are going to design this in the xy plane and click OK. Now click on this icon to fit the antenna. Now a rectangular patch is created. Now let us move to the next step, which is nothing but creating a lambda by 4 transformer. To do this, go to draw rectangle tool and draw one small rectangle. Rename this rectangle as nothing but transformer. Give its color as some green color and click OK and click OK. Now coming on its dimensions. What will be its dimensions? This is the dimension, that is, it is having a wide size of 0.723 millimeter and its x dimension is 8.294 millimeter. That's what I am going to say. My x direction is 8.294 millimeter and my y direction is nothing but 0.723 millimeter. Don't worry friends, I am going to keep this in the description. I am going to keep a link to these figures in the description. You can see the figure from there. Next, and now coming on to this position, its x position, as I have drawn this antenna with the at 6.28 is that its x position is correct. Now coming on to its y position, it will be nothing but negative 0.3615. And as you can guess, this is the y dimension I got by just halving by just reducing this distance by half, or by dividing this distance by half. That is 0.723 divided by 2 will give you 0.36154 and its z position will be 0. Click OK and click on this to there. Now you can observe that a rectangular patch is created and also a lambda by 4 transformer line is also created. Next, let me design my feed point. To do this, again go select draw rectangle tool and draw one small rectangle like this. Name this rectangle as nothing but feed point. Give its color like some pink color, let us suppose, and click OK and click OK. Now coming on to its dimensions will be nothing but 14.94, and then first let us begin with its x size and what will be its y dimension and what will be x dimension. Y size will be 3.059 millimeter and our x size will be 14.896 millimeter. Give the same dimensions here. 14 point, I guess it's 14 point, right? Yeah, it's 14.896 millimeter and the y direction is nothing but 3.059 millimeter. Now coming on to its position, its x position is same, but let me change its y position. Its y position will become negative 1.5295, 0 and click OK. Oh yes, you need to make sure, as I have kept two negative signs, it is saying invalid. Just delete it. It will be this and click OK. Now you can observe that I have created my rectangular patch. I have also created my lambda by 4 transformer line and I have also created my feed point. Now you may ask me, what should I do next? Next we will be creating a ground plane and also a substrate. But I advise you, first you draw the ground plane and then you draw the substrate, because both the ground plane as well as substrate is having the same dimension. That is, both are having its y dimension as 35.9 millimeter and its x dimension is 58.94 millimeter. Or else let us see. This dimension need not be the same. It can vary according to your design. Now to do this, click on draw rectangle and draw one rectangle like this. The main important thing in creating a subset or ground plane, it should be that the edge of a feed point feed point and ground plane or substrate should align with each other. To do this, let me rename a rectangle as ground. Rectangle as my ground. Let me give its color like some brown color and click OK. Let me just say OK. Now coming on its dimension, as I have mentioned, its x dimension and y dimension will be little varied. That is, I am keeping my x direction as 49.47 and my y dimension will be nothing but 35.9. You may ask me, Yashwardhan, that while creating this you have given your y direction y size as 35.9 only, but why are you giving your x size as 50 instead of 58.94? Why you gave it as 49.97? And also you need to set the position as minus 20 comma minus 18 comma 0 initially and click OK. Now you will understand that. Now if I let me zoom it here, you will understand that why I created with those dimensions. You can observe that now if I keep these dimensions, then you can observe that the edge of a feed point and also a ground plane are in line with each other. That is, they are both coinciding, which is the required condition. And also our antenna is like this. Now this is a required dimensions. And also if you want, you can, I will show you one thing. Go to measure, get the position, and now if I see the position here, it is showing as 9.22 millimeter. Same thing if I do from here to here, and you will see that it is also showing 9.2 millimeter. Sorry. Okay, yeah. See, this is x distance is nothing but 9.22 millimeter. That is, it is now a patch antenna is rectangular patch is at the equal distance from each edge. That's the required combination. And click. Just you can now ignore this. Close it. Now this is a rectangle. Now friends, this after trying so many times, I am doing this video, so I know this dimension. But if you are doing this for the first time and or you are using some other values, it is always best you can just measure this distance and accordingly change the values of your dimensions. Now this is a ground plane. Now let me also create the substrate. A substrate is nothing but a box, so click on draw a box and draw one small box like this. Let me name my box as substrate. Then its material is nothing but FR4 epoxy, which is having a relative permittivity of 4.4, relative permittivity of 4.4, permeability of 1, and click OK. And let me select my color as like this blue color and click OK. And click OK. Now coming on its dimensions. What are its dimensions, you may ask me? Its dimensions are nothing but its x dimension is also same as my ground plane, which is nothing but 49.47. Its y dimension is again the same as my ground plane, which is 35.9 only. And what will be a z direction? If you see this figure, I said my height is 1.66 millimeter and it is in xy plane. That is, it should be in negative z direction. So my z size will be minus of 1.6 millimeter. Now what will be its position? Its position will be the same as my ground plane, which is nothing but minus 20 minus 18 0 degrees, 0 millimeter, and click OK. Now you can observe one thing. According to the figure, our ground plane should be below the substrate, but now it is above. That is, now to do this, just go to the parameters of a ground plane and change the x position as negative 1.6 millimeter, because a substrate is of 1.6 millimeter. It should be below the substrate. Just click OK. Now you can observe. Let me rotate it and show you. You can observe my ground plane is down. Next, what should I, now you can say, Yashwardhan, you have created the antenna and you have created the model. Now what should I do next? Next, let us go to give excitations to a various excitations to a diagram. Before we do that, let me first unite, if you can observe my figure now, you may say, you can easily tell that my rectangular patch, my lambda by 4 transformer line, and also my feed points are not in, they are separate figures, they are not united. So if I give any excitation here, there will be little bit droppage. To avoid this, first of all, let me unite this. To do this, just select your feed point, ground, not ground, sorry, feed point, patch and transformer. Right click on it, go to edit, go to boolean and say unite. Now you can observe that all the three has been united as a single figure. Now you can observe that, let me enlarge this, and you can see that it has united your patch. And you can also observe that it has become pink color. This is because first of all what I selected is feed point, which is having pink color, so a whole antenna is in pink. Now that's it. Now let us proceed to giving various excitations and field points. So first of all, let me give the excitation. Friends, now you can say that Yashwardhan, you have designed your antenna and you also united your feed point, your patch, my lambda by 4 transformer line, and also a feed point. Now what should I do? Now before we proceed further, let us first give the various excitations to our plane. So let us suppose first is a ground plane. Let me go to ground, right click on it, go to assign boundary and select perfect electric field. Leave everything in default and deselect your infinite ground plane and click OK. Similarly, go to substrate, not substrate, sorry. Go to this, go to feed point, right click on it, go to assign boundary and assign an electric field and select OK. Now, before we proceed, let us first see this excitation. Go to HFSS design, boundaries and click on perfect electric field. You will see that our ground has in the excitation and select the perfect electric field and the patch antenna is also, rectangular patch antenna is also having the excitation. Now let us proceed further. Now before we do this, next we will create a excitation. To create an excitation, go to here, select your friends. Now you have given your excitations. You have given the excitation to both a patch antenna as well as to the ground. Before we proceed further, let me first create the next thing, which is nothing but nothing but source to excite an antenna. To do this, change your axis to YZ axis. Select draw rectangle and draw one rectangle with the same dimensions like this. Now, rename your rectangle. What should be a rectangle, you may ask me? It is nothing but my source. Source. Let me give my source color as yellow. Click OK and click OK. Now what will be its dimension? Its dimensions will be nothing but our y dimension is same as that of the feed point and our x dimension should be this distance, which is nothing but negative 1.6 millimeter. So let us give those dimensions. Its y dimension is 29.47. Its x dimension is nothing but minus 1.529. Click 0 OK. Its axis should be x axis. Its y size, it should be 3.0 okay 59, and its z direction should be negative 1.6 millimeter. Click OK. Now you can observe, see, this is my source. Now let me assign the excitation. To do this, go select the source, right click on it, go to assign excitation, lambda port. It's having its resistance as 0, reactance is resistance as 50 ohms, reactance is 0 ohms. Click next. select the integration line as a new line. Now go to the middle of this, and from this middle draw a rectangle. This will be my excitation direction, and click next and leave everything in default and click finish. Now go to excitation, right click on it, and you see a excitation is also S sign. Now right click on it and everything is over. Now this is my rectangular patch antenna which I have designed. This is a rectangular patch antenna that I have designed. Now let us, before we proceed further, let us first create a radiation box or outer field where outer space where an antenna is going to propagate. To do this, again change your axis as XY axis. Go to Now go to draw a box and draw one small box like this. Now name your box as nothing but radiation. Then give its material as air or vacuum. Anything is fine. Now let me give it as light blue color. Click OK. As it is the outer radiation box, give its transparency more than 0.9. Let us say 0.96. Click OK. Click OK. Now coming on its dimensions, right click on it. It's give the dimensions also. Its dimension is exposition will be nothing but minus 60, comma, y dimension is 0 minus 30, and z is nothing but minus 16.02. Don't worry friends, these are dimensions which I have created after giving a number of tries. You can also perform a different number of tries and see which values are satisfying your design. Give my x size as 120. Give the y size as 60 millimeter, and z size should be nothing but 30.44 millimeter. Click OK. Now you may ask me, Yashwardhan, how you are created? You should, whenever you are assigning your radiation box, you should make sure that that your whole design is at the middle of this radiation box. Now it is at the middle. Now first let me give the radiation to this also. Go to assign boundary. Go to radiation. Click radiating only. Click OK. Now radiation is also created. Now with this now you can say that you have completed designing your rectangular patch antenna having a rectangular patch. Microstrip patch antenna having a rectangular patch. Now you can begin go on to an analyzing step. Friends, now you can say Yashwardhan, you have created your design very well. Now what should I do next? That is, now what should I do? That is, now you have created your design. Now let us go to analysis. Go to analysis, click add a solution setup. Keep your maximum solution as 52.5 it is only 5.2 gigahertz. Number of passes you give as 25, otherwise you may get an error saying that the adaptive passes are not converging. Click OK. Next, go to analysis, select the solution setup and click on add frequency sweep. Select the sweep type as fast. Select its type as linear step. Select start. Let me start as I am going to generate all the solution as 5.2 gigahertz. So let me say my starting frequency is 1 gigahertz and stop frequency is 10 gigahertz with a subset of 0.1, and I click on display to see all the values at which it is going to plot and click OK. Next, I am going to analyze my design. To do this, click on validate to validate your design. Then click on analysis to analyze your design. Okay, if you are doing this badly, you can pause the video at whatever step you are. Do up to that step and then proceed watching with my video. And if you are having any problem in creating this antenna, or that is if you have taken some other parameters, you can also comment that below. I may be able to help you also with that. Friends, now you can see that my analysis is over and I've got a normal completions of simulation on server, which means there is no error with my design. Now let us proceed to analyze all the differences. To do that, go to results, right click on it, create model solution data report, select the rectangular plot. In this, select the category as parameter, quantity as S11, and my function as decibels. Click on new report. You observe you get a graph like this. Now let us see what is the return loss of this antenna. To do this, right click on it, select marker, add a marker, and add the marker at 5.2 gigahertz. This is my solution frequency at 5.2 gigahertz. I am having a return loss of minus 15.7302, which is a good thing because for any patch antenna, the return loss should be less than minus 10, which is in this case it is satisfying that. Now let me also plot that. Let me rename this also for me as plot 1. Okay, go to results, click on create model solution report, go to rectangular plot. In this, select VSWR and click on new report. Yeah, now keep it at now select add a marker and add the marker here. Now you can observe that I am getting it as 1.3909, which is the correct value. Sorry friends, I kept the function in decibels. It should be in none. Sorry. You be careful. This is also good because it should be in the required range only. Now let us proceed to other things. Now you may ask me, just me rename this as VSWR only. Sorry. Now let me go to, now you may ask me, Yashwardhan, now I want to analyze my radiation plot, that is in 3D plot. To do this, go to radiation, click on assign far field setup, infinite sphere, select phi as starting at 0 degrees to 360 with a step size of 10, and say that our theta starts at minus 180 degrees and it is stopping at 180 degrees with a step size of 10, and click OK. See this? Now let us proceed with other things. Go to results, go to far field report. In this, go to 3D polar plot, select your category as gain total, and my function should be in decibels. Click on new report. See, this is my thing, and if you observe, my maximum value of gain is 5.3902, which is also good. Now let us observe this in 2D plot. To do this, go to results, go to far field report. In this, instead of going to 3D polar plot, go to radiation pattern, select gain total none, gain total, and function you select it as decibels, and just say new report. And this is the game plot in 2D. Now again click on add marker and add the marker at 0. You will observe this is the magnitude. At some other points, if you want, you can also observe the value gain magnitude at that time, and also you can observe the angle and theta also. Just say it as 2D plot. Okay, yeah. Now let us proceed with other things. Go to results. Now, yeah, go to results. That's it. These are the things. Now if you want, you can see the different graphs or other graphs also. Now let me say how you can visualize your electric field and magnetic field on this. To do that, open sheets. In that sheets, go to the perfect, go to feed, select the feed point, feed object. Now go to plot fields, electric field, magnitude of electric field, and click save as default and click done. See, now you can observe this field. Now, okay, now friends, you may say that Yashwardhan, I'm not able to see this clearly because I have kept my substrate is also blue color. Okay, just let me change that. Go to substrate and let me change my substrate color to, let us say, some light color like this color and click OK. Click OK. Yeah. Now you can observe my radiation field. Now let us see its animation, that is in what my electric field here. To do that, go to field overlays, click on electric field, select magnitude of it and go to animate. And if you want, you can start at 0 degrees, 0 to 150 or 0 to 170, whatever you want. Let me say 0 to 150 with a step size of let us say 15. Click OK. Okay, and now you can see this is how my electric field is propagating. Similarly, you may say, Yashwardhan, I don't want to see my electric field, I want to see the magnetic field. For that also, go to field, select the feed point, go to plot fields, select the magnetic field, magnitude of H, save as default, click done. And again, this has been created. Now again, go to magnitude of H and just say animate, click OK. And it will animate your magnetic field also. There's no problem in that also. Yeah. Yes, see, now you can see the propagation of my magnetic field also. Now friends, hi friends, I hope you have enjoyed my you liked my explanation on how to create a rectangular patch antenna, Microstrip patch antenna using HFSS software. If you have any, if you get any doubts, please feel free to comment that down below. And also, if you have any ideas on what kind of project should I create next, you can comment that also in the down below. And if you like my explanation, please like this video, share it with your friends, and do subscribe my channel to see more such videos. Thanks for watching friends, and have a nice day.